First, we've got scientific notation here. Scientific notation you see is made up of a couple different parts. First, we've got this number here. It needs a single digit to the left of the decimal place. And then over here, we've got the times 10 to the power of 4, which is the exponent. That's the other part of scientific notation. You see that this one has a positive 4, which means that the standard notation number has a value greater than 1. If it were negative, then it would be less than 1. Now we're going to look at going from standard notation numbers to scientific notation numbers. This number right here, that's in standard notation, that's what we're used to, and we're going to need to get it to scientific notation. Like we said before, we need to get that to where the decimal place only has one digit to the left of it. So in this case, looking at 5,277, the standard notation, 5 is going to be the number that is going to be the left of it. So that's the only thing that can be on the left of the decimal, which means that between 5 and 2 is where we need that decimal. So 5.277 times 10. And now we need to see how far the decimal had to move to be able to find this exponent right here. The decimal starts right after this 7, and moves over 3 times, which means that our exponent will be 3. Now we have to figure out, is it a positive 3 or a negative 3? Looking at this standard notation, if it is greater than 1, then it'll be a positive exponent. If it were less than 1, that would give us a negative exponent. Since 5,277 is greater than 1, it is positive 3. Now 27.3, we've got to have a decimal between 2 and 7, so that 2 is the only thing to the left of it. That gives us 2.73 times 10. Again, need to find that exponent. It moved 1 time. 27.3 is greater than 1, so we're going to have a positive exponent, so positive 1. We've got part C, 0.00891. To get a single digit to the left of the decimal, it needs to be between 8 and 9. Gives us 8.91 times 10. Looking back at the standard notation, we need to know how many times we moved. We moved 1, 2, 3 times. Again, this standard notation, 0.00891, is less than 1, which means that since it's less than 1, than 1 means a negative exponent. So it'll be times 10 to the negative 3. Part D, we've got 0.00001728. Decimal needs between 1 and 7. 1.728 times 10. How many times does the decimal move? We've got 5 times. You need to look at the standard notation number. It's less than 1, so it gives us a negative exponent here. We've got, to go back from scientific notation to standard notation, we've got to do just the opposite. We are going to look at the exponent, and that will tell us how we need to move. So first, I'm going to move these down to give myself a little bit more room. And looking at this 4, it's a positive 4. That means that my standard notation needs to be greater than 1. And if I look at my decimal here, to make this number greater than 1, I'm going to need to move it to the right. Positive means greater than 1, so it needs to move to the right to get it greater than 1. I need to move it 4 times, so cut in. Need to move it 4 times, so 1, 2, 3, 4. and need to add a placeholding 0 right there. So 1.1210. Cut. So 11210. B, we've got a -2 exponent. That means that my standard notation has to be less than 1. Decimal place moved 2 times, so let's rewrite that. I've got 2990. Decimal place was right here, and it moved twice, 1, 2. Placeholding 0, and decimal is now here. You can also add a 0 in front of it if you prefer. Then part C, we've got -5, which means that it's less than 1, and decimal moved 5 times. So 501, decimal was right here. It needs to move 5 times. 1, 2, 3, 4, 5. Fill in with placeholding zeros. Decimal goes there. So I've got 0.00000501. Last one, we've got a +5. Positive means greater than 1, so my decimal is going to be moving to make my standard notation greater than 1. And I've got 971, decimal was here, 1, 2, 3, 4, 5. So hopefully between this video and the last video, that will have helped answer some questions for you. Let me know if you do have any other questions, or if you still have a question on this in a private comment, and I will be happy to do my best to answer those questions. Thank you.